All right. Hi, everybody. This is Kubernetes Workgroup Device Management meeting for August 6th. Let me quickly share the agenda. So a couple items today. I think we also talked about going through a bunch of these planning items. But Kevin and Patrick are out today, so I think Patrick is out. I didn't see him on the call, and so it may be better to wait on that till they're here. But in any case, other items. Kevin, like I said, he's out today, but he did want us to mention that he has a PR open for the example driver, so people can check that out. It's got the changes for 131. Please give him some feedback. And as he says, suggestions and PRs are welcome. So with that, I guess I'll hand over to Antonio, who has a demo he's planning on doing.
I had some slides to provide a bit of context because
Out how to give you co-host.
that's share the
No,
screen. No, I'm not able to share.
yeah, I'll be. Just give me a sec. Okay, now you should be able to share.
Am I sharing? Can you see my
Yes.
screen? Okay.
Yes.
Okay. Well, this is a presentation about using the array for providing. I call it Kubernetes network drivers, but it's just to implement network features using the array. Some of you know me. I'm a TL in SIG Network. I've been in Kubernetes SIG Network for a long time. And from SIG Network, we come to DRA from. We started this path with the multi-network, right? We in SIG Network there is a need for some areas like telco now with AI, ML, and other features that require more network capabilities. And there were two caps that were trying to solve this problem from different angles, right? The first cap, the 3698, wants to create a more network specific API like in a typical IaaS provider, more with the SDN concept. There is network, there is subnets, all these objects. Like people that is familiar with OpenStack will be some resemblance with API. Then I think Mike Zappa is in the call. Mike Zappa took another approach. Say, okay, why instead of solving the high level problem, we solve the I'm going to call it low level. Mike, feel free to chime in and correct me if I'm wrong. Right? How the interaction with the Kubernetes components, CNI is very constrained, and what if we can enrich these low level primitives or APIs to provide more flexibility and grow from there. So those steps got a bit stuck. There were controversial points, conflicting points. That's not the point here. Well, but after several discussions, right, we we found a common denominator. That is, okay, we want to provide capabilities to configure network interfaces and provide configuration and make this dynamic. And with all of this, I put together some slides in SIG Network in March 14 that say, okay, we can use device plugins to provide not to solve the whole networking problem, but at least the additional network interfaces. But when I was doing the device plugin, I realized that I missed some capabilities. So I was talking with Tim Hawking offline and I started to hack the device plugin. And that's when he told me, well, talk with Patrick, with Kevin, with John. We are revisiting the array, and the thing that you are proposing in your branch that you are experimenting is the same thing, or at least the same goals that they have. So that I presented this in the Contributor Summit in Paris. The future of Kubernetes networking can be done using the array. That's from C Network. That's our expectation of this project and from this working group.
Yeah, Antonio, uh, your audio keeps kind of fading in and out. I don't know if you
Okay,
can
so
adjust
maybe
your
it's the
microphone. Yeah, thank you.
yeah. Thank you. Okay, so then we are going to base this network drivers on these user stories. It doesn't cover all the user stories, but I think that this is simple for the people to understand, right? We have now these machines that have GPUs and required to add NICs, and maybe these NICs has an RDMA devices that also need to attach. But also this GPU has a relation with the PCI route and the NIC. So this makes very complex to be able to provide capabilities to schedule pods that match all these concerns. The other user story that is very clear is typically for the storage applications. They usually connect to external VLANs or subnets on bare metal or data centers, and they want to use the second interface to provide the connection to the store, right? The other common one is that you may have a pod that is connected to the normal network and then have two interfaces. Let's call it east and west. And you want to throw the traffic through this east and west, right? And still keep connecting to the main application through the main interface. And another one that is popping up recently, at least from my point of view, is about on cloud providers that be able to connect to different VPCs, right? Is the pod may be connected to the cluster, but in addition to the cluster, want to have a connected to a second VPC that has, I don't know, a database or a private service. So these are the user stories that we are trying to cover with this the array and networking. So for how is Kubernetes networking working today and why this doesn't work for us? When you run a pod, the kubelet performs two CRI operations. One is that run pod sandbox. Run pod sandbox creates the network namespace. And in this creation of the network namespace, the container runtime decide use CNI as the protocol to communicate with a plugin that receives a CNI add and provide the interface and the IPs. After this rampod sandbox RPC call ends, it returns the pod IPs to the kubelet and the kubelet update the pod spec. Then once this operation finishes, it starts create containers. There is someone that is talking. I don't know, Jonathan. Maybe it's you. You can go mute. Thank you. Okay, so what with this the project where the CNI was used as by the network plugins to provide all kind of functionality. So the project and Kubernetes ecosystem grew holistically over this CNI interface. So right now you have plugins like Cilium, Calico, or other things that provide all the networking features based on the CNI. But what's the problem? The problem is that you use the CNI to build all these networking features. You don't have any way of receiving metadata or information. So what typically these network plugins use is to do CRD. So when they receive the CNI call, they perform another API call to do more operations. So this causes scale problems, performance problems, and reliability problems that one example is this. This is the what happens when the Cilium agent receives a CNI call. See all the list of operations. In theory, when CNI was created, was to receive an add request, another IP, add an IP, an interface, and return. And nowadays, it's doing a lot of stuff. And op, every operation in this diagram is a single point of failure, and adding latency that is very critical these days for all the workloads. So based on that, I started to investigate. Okay, where let's. This is a diagram with the operations that happen during the pod creation. You can see that there is the Rampod sandbox RPC that I called it before, and now they create containers. So based on that, we can observe that there are OCI hooks that permit to exec things after the CNI. So the goal is, do we need to build everything on the CNI? And that's the investigation that I started. Okay, so we have OCI hooks. Can we use them? And then if we have OCI hooks, how can we send information to them? How can we provide metadata to them? And I found that the device plugin are also sending some information on the pre-start container hook. Trying to put all together, it can work, but doesn't work fine. First, we have a lot of the networking ecosystem have a lot of implementation based on annotation. And second, the device plugin still doesn't remove the need for annotations. So that's a bit of the history why we ended in DRA as the solution, because DRA is providing all these things. It's providing a capability to add information during the pod creation, and the capability to offer flexibility and APIs to not have to use annotations. The way that it will look like, you saw at the beginning, I started with some diagram. This is a bit more complex, but in this case, you can see that the cube, the operation should be the same, with the difference that in this case, we can use NRI to provide. I thought that I had some slides for NRI, and I just don't know where I put them. Okay, I just did it the other way around. So sorry. Just forgive me your context. When you are in the way this should be before. When you are in the process of creating the pod, you can use CDI that is heavily used by all the DRI ecosystem and everything, and is able to provide this information and these callbacks on the OCI hooks. But I found this a bit problematic for networking, because it depends on writing files on the file system and the container runtime, and it can be raised. So there is another feature in the container runtime that is called NRI plugins, that are gRPC plugins that allow you to to implement callbacks in two important hooks for the network. The Rampod sandbox, that is when you, after the CNI run, it calls you with the namespace. So at this point, the network plugin is able to perform all the networking operations before the containers start. And in the stop pod sandbox, that is when you need to clean up. Okay. Sorry for going back and forth. So based on that is, we can create network drivers using DRI and NRI that simplify a lot the complexity of adding this secondary network interface, and can use DRI to provide these nice capabilities like scheduling or flexibility, or well, I don't know what else. But so I prepare a quick demo that you can use with a kind cluster. This is okay, the audio is still wrong. I see that. So let me share my other screen. New share. Window terminal. Okay, now I'm sharing my screen. Are you able to see the screen?
Yes, it's pretty small, but I guess it depends how big your
No,
screen is
okay.
at home.
Let me.
That's better. You made it bigger. It's better. That's
Okay.
pretty good. Yeah, there we go.
Okay. So the first thing is the. Okay. Let me. So you can install the driver as the driver is a simple Golang application. It's the business logic is about 500 lines of code and it's very simple. You just get an interface and plant the interface into the network namespace. Right? I wanted to make it simple. It just needs netadmin and sysadmin capabilities because you need to go into network namespace and do networking stuff. So then you need to mount several folders, right? There's the plugins, the NRI path that is where you hook the NRI plugin to containerd and to mount the NetNS to be able to jump between network namespaces. So first thing is we need to install the cluster is a kind cluster. Okay, you have the install in the repo. Or if you want to use it, you have login and everything. Okay, just need to patch containerd and enable the feature gates and the Alpha APIs. Okay, the cluster has been created, and now we need to install the plugin. Once we install the plugin, pause, app driver. We have the plugin is running. We can get logs from 1.10 to see what they are doing. So, well, it's very verbose, but at one point you see that they are not publishing practically anything. They are connecting and starting one controller. It's time to find interfaces, and with the interfaces they publish the what's the name resource slices. Resource slices. No, what is the name of the
Yeah,
get
yeah. Get resource slices. Yeah.
so resource slices? Okay, and then you see that the control planes has one interface and
Can you? Yeah.
and
Yeah. YAML it. Yeah.
I added all these attributes, right? This is free. This is the good thing from the new API in 131 that you can add all this stuff. And the best thing is that you can write expressions to match on this thing. So you see that this matching interfaces, BS interface, right? You can filter in your logic. I don't want to match on this. But anyway, just let's follow. Then I prepare some example. So let me the demo is about one DAM interface that we want to put one DAM interface inside a pod. So in examples, let me create this DAM interface. A DAM interface. Okay, I'm going to create this DAM interface in this worker. Okay, so when I create the DAM interface, now I'm going to have. Oh, sorry. In the agent on the driver on the corresponding worker is going to have this this YAML interface. You see, is matching the is translating to a resource slice the interface because we have the logic to discover this. Okay, now what the following example we have a device class. This is going to match on this DAM interface. Say, okay, I want my users in my cluster to be able to reference the DAM interface. So I write this cell expression. Okay, you need to match the name of the driver, and then on the name of the driver, you want to match the interface that has this type dummy. But this can be IP, that can be any of these attributes that you saw before. So let's apply this. Mm, the device classes. Okay, so we have the device class. I don't know why it auto completes. Okay, it's there. Now, for the example, let's do the one with resource claim template. Okay, so the resource claim template is going to say request a device from this class. The class as we saw before, is going to say request any device that matches that the type is dummy. Okay, and the pod just has a claim to the claim template, and the container reference this claim. So this pod has to be scheduled on the DRI worker. Yeah.
So I think, Antonio, just FYI, I think you don't, for network interfaces, since they're pod level, not container level, I don't think you actually even have to put the resource claims in there.
Yeah.
You're not supposed to
Here.
have to. Now but so we should make sure it works without that for the network interfaces.
Yeah. I also had this feedback today. I didn't know. I didn't have time to test it, but
Yeah, that's
that's
fine.
definitely something that the networking community wants to. Lionel is raising his hand, so I think that he was just going to say that we shouldn't have to do that.
Yeah, I tried it, but I don't see it in the CAP or in any documentation. So I was not sure if it was a feature or it was something that was missing in the array.
It's supposed to be there. We had a discussion about it, like in the code reviews, whether it may not have been documented properly. So we should make sure that that works.
Okay, yeah, maybe I missed it then. Yeah, okay, perfect, thanks.
In the node prepare in the code reviews, we talked about node prepare resources should get called in the 130 code. It doesn't get called unless unless there's some container that's consuming a claim, but that we were supposed to have changed that, and we did that in the code review. But I don't, I'm pretty sure what merged calls it, even if there's nothing there, but I can't say for sure.
Okay, I tried before. I mean, I tried in 130 and then I tried in 131, and both were working fine. So, but I didn't see any documentation, so I wasn't sure.
Okay.
Okay. Well, so in theory, I can skip this and let's do it to not find a bug or figure out during the demo. Oh, Abhishek has a hands up. Yeah.
Abhishek? Oh, okay. He's having issues with his audio.
Should we wait or we can keep going and we follow up?
Keep going, and
Sure.
we'll see. Yeah, that we can ping. We'll see what his question is.
I will continue. So then this is going to apply, as you see, it's going to a pod that is referencing this claim template that is referencing this device class should get the pod this dummy interface. Okay. Examples, template. So now we see the pod is running. We see the resource claim. Get resource claim. So we see that the resource claim template generate a resource claim, and the resource claim got allocated right to the pod. And if we get the pod, zero IPA, why is not working? I think it. We see that the DAM interface got moved into the pod. Okay, so and that we go to the worker node, we can see that the IP is not here, right? It got moved inside. If we delete the pod, it's a DAM interface, so the interface got destroyed. So what I'm going to do, the second example is it's just this time is with emulating that somebody wants to provide a fixed IP to the pod, right? This is not working. It's just for the sake of doing an example.
Previously in your config, you had DHCP there. Did it allocate a DHCP address, or that part's not working?
No, that's just for examples of.
Okay.
It's just to provide a more how I envision people should use it. But this is just moving the interface in and out. But the plugin, the driver code is receiving all this information. So that means that we can implement all these features. I think that for the networking people, we should talk and reuse most of the existing configuration parameters to make a smooth transition. But basically, is in this opaque config place, we can pass all these parameters, get all these parameters, and apply this configuration. The feedback that we need from the array is we need a status thing for returning the state of these operations.
Right. So question though. Okay, so now you're showing. Previously, you showed that in the device class it said DHCP, but now this is the resource claim, and you're saying in the resource claim you're saying opaque config, and you're asking for a static IP. So what we have to figure out, like both of those, well, if you use the same device class that's got the DHCP, then both of those configs go to the driver. So it's up to the driver to decide which configuration takes precedence. And so, yeah, we'll have to sort of document and come up with conventions and kind of work. The networking team will have to work together to figure out like how they want it to work. Because right, you could have a device class that's got no IPAM configuration, and then you require it in the resource claim in order to get an IP. But if somebody uses a device class with some IPAM and also adds IPAM to the resource claim, which one wins? Like I don't know what you want to do. So
yeah, well, I just was trying to emphasize the capabilities that this has to give me an interface. I just want an interface versus give me this interface. I want this interface with this characteristic with this IP, because the IP, I mean, the IP is an example, but it can be IP or it can be a specific VLAN or a specific MAC address or whatever.
Right.
And what I'm saying is you have this capability now that we didn't have with the device plugins or with the previous method, right?
Awesome.
I'm able to I'm saying DHCP because this is going to land anywhere. I don't want to be worried about the IP. I just want about this type of interface. And as you see, this is what gets into the driver. So I have all this information. What we need from networking is we need to report back because we are going to do operations. If I say in DHCP, I'm going to be able to say, oh, as a result of this configuration, I gave this IP to this interface. And we don't have now. So it's a request for this working group. We need some way of reporting. I like the opaque thing because allows to provide some structure and not get tied to the implementation. And usually with networking it's hard to get agreement, but I think I'm very open to whatever the working group decide. But my feedback is this opaque thing is really nice because allows you to provide configuration and structure. And
yeah. So that's awesome. Thank you. And yeah, I agree. I think in 131, there definitely was a need. We recognize this need that you're talking about, and this demonstrates it really clearly. But we weren't able to get it in. But what we would like, so in 131, the suggested workaround is to have a CR that you would write that information to. That's not ideal, but it would work. But I think that in 132, there's a cap. This gets back to the planning discussion. There's a proposed cap. There's no PR or anything for this, not even an issue. I just have a list in our agenda document of about a dozen different enhancements we can make on top of the 131 code. So those would all likely be separate caps with separate feature gates, but maybe some of them can be added during beta. I don't know. We need to get something to beta. So, but in any case, this feature, exactly what you're talking about, is one of them. So I'd love to work together to make sure it meets the needs you have here.
There are several questions on hands. So how do we want to proceed?
Who raised their hand first?
I did, but that was first. if you want to go with chat first.
Oh, there's one in chat.
This is for you, John. I don't know the device
Okay.
kernel name. I think that the device
Okay.
kernel name is cluster scope, right?
Yeah. So device classes are cluster scoped. So the way we can control the only way we can control access right now is through quota. So the namespace can have a quota for on a per device class basis. So if you set that quota to 0, then you would restrict it. The other way is, you could use a VAP, right, a validating admission policy, but that's kind of painful. So quota is the only mechanism we have for managing that right now. So Abhishek, I'd love to understand what additional use cases you have around that, but right now that's all we've got. I guess you can't respond because your audio is not working, but and then Rita, okay.
You might want to repeat the question for recording.
Oh, good idea. Okay. So Abhishek's question was, did I read it out loud? How does the user know the device class name, and if the user has access to the defined class? The answer was right now it's quota is the only way to manage that. Rita says that there's implicit sharing of network namespaces among containers in a pod, which complicates the application of resource claims to network resources. How does this solution support claims to networking resources for a subset of containers?
Let me take.
Okay.
This is what I tried to explain at the beginning. So the container, there is no sharing. It's all the container has the same network namespace. Well, sorry, I lost my window. Where is my window?
I don't know. I see your.
Okay. I say. So all the containers share the same network namespace. So there is no network namespace isolation between containers. The only problem that Mike. So the only problem that you have in the networking side that I've seen is the interfaces that use RDMA, like this Mellanox NIC card, right? Because in addition to the NIC that is pod namespace, they require to mount the RDMA device that is container level. But for the rest, it doesn't matter. You cannot provide namespace isolation between containers in a pod. All of them share the same network namespace.
Okay, I can go next. My question is, your first scenario, Antonio, was sharing, like picking the network that is connected to the GPU device. And in this example, you kind of selected everything by name. So I wonder how you envision this scenario will be solved. And given I'm not very proficient in how networking will work in this case.
I make this on purpose to not make it by name. I make it by type. Type is the interfaces in Linux can be of type BS, of type Ethernet, of type dummy, right? So if you go to a I don't know if it's shown here.
So Antonio, I can probably take this. I think Sergey's question is more of a DRA API question. So if you want to show your resource claim, you can see the resource claim. Each resource claim has not the status, but the spec, please. Thank you. Each resource claim has multiple requests. And right now, there's just one request in here. It's a request for dummy interface. Now, if we were requesting both a GPU and an interface, we would have two requests in here. So you'd have request one that gets the GPU and request two that gets the NIC. And then there's another section that would appear parallel to requests called constraints. And constraints allows you to specify additional constraints, additional rules that control the device selection amongst those requests. So each request has a selector or multiple selectors that allow it to filter what kind of devices from the whole field of devices might meet that request. And then on top of that, you have constraints, which are on top of the set of selected devices. So in that case, you'd say in your constraint section that you have a match attributes constraint for the PCIe root. And what that would, and it applies to, and you'd list the requests it applies to. So it applies to the GPU request and it applies to the NIC request. So that would make sure then you'd only satisfy the scheduling problem if the selected devices have that attribute matching.
Cool. Okay. And is this will be known by scheduler or by kubelet
yes,
only? Okay.
By scheduler. Cool. The decision is made. The specific devices are chosen by scheduler to meet those constraints.
So this is the GPU 0 need to be in the same NIC that in the same root PCI complex problem?
Yes.
Okay. Sorry, I didn't.
Yeah, I don't think Antonio demonstrated that. Yeah, Antonio didn't demonstrate that because he's just focused on the networking side right now. But that's the cross driver. Now, in order for that to work, the networking driver and the GPU driver have to agree on the attribute name, right? And that's something we haven't done yet for 131, but we need to do for beta. In 132 is we need to come up with at least a couple of these use cases that are going to work cross driver and have each driver publish their attribute with the same name and the same format, value format.
Yeah, makes sense. Thank you.
I just put in the chat a link to a slide that I have that demonstrates this.
Awesome. Thank you, Kevin. Thanks for joining. Peter.
Thank you. Hi, everybody. My question is more likely focusing this put sandbox is triggering the NRI, but where NRI getting the input? So where that which type of interface on which node should be created? So where are the inputs for NRI? This is my question.
Can you expand? What are the inputs in
for NRI? Because as based on the presentation you mentioned using DRA and NRI, and the DRA part is clear, but what is the input parameters for NRI? This is not really clear for me.
Yeah, so the way that I implemented this is the driver. It's very simple. It's 500 lines of code, right? So
okay,
let me find it here. So this is the NRI hook, okay? The NRI hook receives a pod object, right? That it has the name, UID, and the runtime values, right?
Okay.
But this is called by the container runtime once the pod is being created.
Okay.
But before that, this is public resources. This is the logic that you decide to publish. This is the hook that John was mentioning. The node prepare resources. The kubelet calls your driver with this thing, and in this call is when you get the claims, right? And when you get the claims, I iterate over the claims. Sorry, I'm going faster. I realize that I'm presenting. I iterate over the claims, and when you go to a specific claim, what I'm doing, that is, you need to get the claim because there's queue problems. Kevin and John clarified this to me. That's meant when you get the claim, you get access to all this information that we say reserved for config, these opaque values, devices things, all this information. I store it in a where is the here pod allocations at. This is a small cache that I built. So the small cache. Now I'm going back for it. Right? It just has the UID and the allocation result. So when I in the RAM pod sandbox hook, I have all these values from the climate spec. And in the climate spec, I have all this information, config and whatever thing. So all the DRI configuration, I mean, it's up to you. I'm using verbatim the client, but if you have some specific logic, you can transform the data and provide to whatever thing you want to run here. Does it make sense?
Yeah, because earlier I checked what Yoni presented, and it was a little bit different because they generated an output. If I recall correctly, it was in the resource claim YAML file, and then NRI used this information based on the presentation. But look like you implemented this a little bit differently, and this is the reason I wanted to clarify. Okay, but it's clear for me. Yeah, thanks for the clarification.
Lionel.
Lionel, you can go.
Sorry, I was muted. Yeah, my question was if this node prepare resource request is called when you don't claim from a container, because when I tried it, I didn't need this to implement this.
Yes, it should be. It should be called even if you don't claim from a container. As long as there are resource claims listed, I believe it's called.
That is new in this version. All previous versions, that was not true. So but it is in 131.
The point is, if it's not called, we can open a bug and say right? It's expected to happen.
Mm-hmm. But yeah, in the latest version that I tried, I didn't implement this, so it was not called. I need to look into it more in detail. Thanks.
Well, I mean, there is no more. I mean, the code is very simple, and I made it that way just so everybody can do their drivers, play with it, and provide feedback. You have also, I mean, the repo is in the slides. So if there is no
Antonio,
more question, yeah.
I have a related question. Is there anything you found? Because I assume you based your implementation off of the example driver that I put together. Is there anything you found in that that's worth contributing back, bugs and/or comments to put there so that other people that look at the example driver can benefit from that?
So the thing that I did in the presentation, I evaluated CDI, and I mean there is some way we need to communicate container runtime things with kubelet things, right? And for what I see is there are three things: the CNI that is very complex because you need to end with a lot of loops through the API server. So I discarded that. The CDI was my fair option. I was pretty neat, but the problem is that I found races with writing files and reading files and cleanup and restarts. And I ended up with this NRI because it's also gRPC, and as you can see, it's just for the network, it provides the two hooks that are not in CDI. That is the Rampod sandbox. CDI are based on OCI hooks, so only give you the runtime, the container hooks, but doesn't give these pod sandbox things that are really useful for, or at least I don't remember if CDI is able to give me that. But for that, I based on your plugin. It's really useful. The other thing that I prefer to avoid is to add this third indirection on another CRD. If I can have everything, because there are already two levels of indirection with the device class and the resource template. If I can put all my stuff in the resource claim, in the status, I think that from the networking point of view, it will be a very neat solution.
If you're talking, Kevin, we can't hear you.
Yeah.
Sorry, you came off mute. That's all. Yeah.
The other great value that I see with this is that users can decouple of, oh, I have to implement this for Cilium or for Calico or for the other thing, right? This works with all of them. So you don't have to provide different, because at the end, in these cases that are very clear, that are secondary interfaces that doesn't have any relation with the internal network, you shouldn't depend of I have this version or I have this other version. I just want this interface to be in this product.
Yeah, sorry, I think you can hear me now again. Yeah, I missed the beginning of what you said just then because when you couldn't hear me, I suddenly couldn't hear you, and so it was flipping back and forth. But yeah, so just to make sure I understood. So what you want to be able to put in the claim status is information based on your opaque parameters or just something that you've done that you want to keep track of rather than having to publish your own CRD. Is that right?
Yeah, because the other problem is scale and complexity, and I mean, it's not so many. Basically, you can embed the CRD in the opaque thing, right? So adding another reference make it also more complex.
Yeah, no, I think as John mentioned, we totally have plans for doing this.
Oh,
It's,
awesome. Okay, thank you.
Yeah, it's just that we didn't get it for 131, and because it didn't get it for 131, it probably won't be beta in 132 like the rest of what we have is. And so the earliest that a feature like that would be beta is 133. Because everything has to go through at least an alpha cycle before it can move to a beta cycle. So yeah, we totally plan on allowing that. It's just for now, if you wanted to get it to work along with us going to beta in the next release, the only quote unquote supported way would be to bring along your own CRD for the moment. Yep.
There is a hands up, Marlo.
Yep, Marlo. Yep.
Hi, it's just a quick one, and I guess it's part of this discussion, but it's not specific to the DRA component. Is there a reason you're using NRI as opposed to, say, network service mesh or Multus for the multi-network piece you're talking about underlying?
Yeah, that's the whole. When I started, I tried to provide some background on that. The problem of all these things is that hooking the CNI in the CNI. Let me go back to the presentation. The problem is that all those projects build on top of this hook, and this hook is not meant to be doing that. There is also no way of communicating cleanly through this CNI. CNI spec is very, how can I say, prescriptive about what you can say, right? IPs,
Well,
hosts.
Multus is, but network service mesh is a gRPC component to it.
I'm not familiar with
Yeah.
server mesh, so then it's my ignorance. I just
Yeah, because
I
that
just
one
wanted to
is
say.
well built. Yeah, it's well built, being used by Ericsson, so it might be simpler to just use something that's already there rather than building another pluggable thing.
No, but the goal
Yeah.
here is you have a network driver, right? I mean, what the goal is, this service mesh may that you mentioned may use DRA for implementing all these things, because maybe today they are workarounding this with CRDs or another thing, right? What DRA is building is all these APIs in tree, and what I'm trying to do is move all the networking community to use these native APIs to build these complex network systems. So what maybe all service mesh, all Multus, and all everything can move to do these things that they are doing now their way with DRA.
Yeah, I'm not saying you don't use DRA, because you're still missing the component that you have to expose what is available on the node to the scheduler.
Say again?
You still need to be able to say what the nodes look like all the way up to the scheduler, so you're placed in the right area, which these products don't have.
I miss context, so I cannot.
If you have particular networking components you need available on the node, you still have to expose that to the scheduler, including location.
I think Marla's saying so we'd still use DRA, even she's agreeing with what you're saying, yeah.
Yeah, I'm agreeing with the network service mesh. I'm saying the underlying, I don't think you have to reroute the underlying network stuff because there are people that already have done some basic POCs in the space, not with network service mesh, but with Multus, but there's another possibility with network service mesh.
I can talk about network service mesh, and I don't think it can be applied in DRA. We used it a lot at Ericsson, and I don't see any way to adapt it to DRA at the moment. And the API is very hard to change in network service mesh. CNI could be compared to it, but not DRA.
Okay. Any other thoughts or comments? I don't know that we have time to go through any of the items Kevin did make it, but we could if we want to start. Well, any more questions on this before we move on? I guess. Awesome. Well, thank you, Antonio. This is great to see an example of it in networking and sort of like start to exercise the API and see if we've the other, I think, area I would ask for feedback on is in 131 we really focused on expressiveness of the API, so like making sure we can do the things people need to do, and we didn't focus too much on usability of the API, like how easy it is to use, both from a PodSpec author. Really, the primary person I'm concerned about for usability is the PodSpec author, not all of us who are writing drivers. We can suffer, but the PodSpec authors, there's more of them, and they're not going to be as in depth in their knowledge. So it's still, I think, a little bit hard to use on the PodSpec side. So any feedback you can give there. I mean, you had looked at the device plugin, right? And you know it's pretty easy to put an extended resource in. One of the things we thought about at one point was like, could we tie that same format to device classes? So essentially, you have a way to specify device class / device class name : 4, and that would translate into exact count for that device class with no additional, so the simple cases stay simple. So I'd love feedback going forward. One of the KEPs on that list is exactly this: usability of the API. So it's something we might want to get started on. I don't think we would necessarily even move it to alpha in 132, but it could take a long time to sort out. So your feedback would be helpful there. Any other comments? I'm gonna propose that we just wrap up rather than start to try and go through the dozen or so KEPs there, just since we only have 4 minutes, and Patrick's not here anyway. So if there's nothing else, I will wrap up the call. Okay. Awesome. Thank you all.
Thank you.